In this video, we're going to integrate e raised to the power of e to the x with respect to x. The big idea is to look for an inside function, so we can use substitution and connect it to a known special antiderivative. Let's stay oriented. Our goal is an antiderivative, a function whose derivative gives us back this integrand. Since we see e raised to something complicated, we should ask, what is the inner piece that's causing that complexity? The inner piece is e to the x. A good substitution is to name that inner expression, because it often turns a messy exponential into something simpler. We're renaming the inner expression e to the x. Now we differentiate both sides. This step matters because substitution works by replacing not only the inside expression, but also the differential part. Differentiating keeps the equality true, just in derivative form. We want to swap out dx in the original integral, so we solve this for dx. Since e to the x equals u, we can rewrite the right side in terms of u and isolate dx cleanly. This is what we'll substitute for dx. Now, we substitute everywhere. E to the x becomes u, so e to the power of e to the x becomes e to the u, and dx becomes du over u. That turns the problem into an integral in u only, which is exactly what we want. At this point, it's important to notice a key fact. The integral of e to the u, divided by u, does not simplify into elementary functions like polynomials, exponentials, logs, or trig. Instead, it's a standard special function called the exponential integral. The exponential integral, named ei, is defined so that its derivative is e to the u over u. So, we can use it as the antiderivative of this exact expression, which is why the substitution was the right move. This special function is the antiderivative we need. Now we just undo the substitution. Since u was e to the x, we replace u with e to the x. And don't forget the constant, because any constant disappears when you differentiate. We substitute back. U becomes e to the x. A quick check helps you feel confident. If we differentiate ei of e to the x, the chain rule brings down the derivative of e to the x, which is e to the x, and ei prime gives e to the x divided by e to the x. Those factors cancel, leaving exactly e to the power e to the x. So the final takeaway is, substitution gets us to a known non-elementary integral, and the clean final answer is written using the exponential integral function. That's a very normal outcome when you see e to the u over u show up.